Use the identity cos 2 theta equals 2 cos squared theta minus 1 to prove that cos half of x is equal to square root of 1 plus cos of x over 2, given that x is between 0 and pi. So for question A, we're given the double angle formula for cosine. So cos of 2 theta is equal to 2 cos squared theta minus 1. And we're asked to find an expression for cos of half of x. So here I'll just substitute in half of x for theta. So I can say let theta equals half of x. And I can do this substitution. So 2 times half of x, that'll just become x. So that'll be cos of x is equal to 2 times cos squared of half of x minus 1. Now we need to solve for cos of half of x. So I'll solve this equation, or I'll isolate for cos of half of x. So add 1 to both sides, divide by 2, and take the square root of both sides. And I should get that. And then you should notice that you're given an interval here, that x is between 0 and pi. And so I'm just going to restate that there, and that means that x over 2 is between 0 and pi over 2. And cosine between 0 and pi over 2 is always positive, and so we can ignore this negative here. And so we'll just get that cos of half of x is equal to the positive root of cos of x plus 1 over 2. Question B. Find a similar expression for sine of half of x, given that x is between 0 and pi. Okay, so in this case, they want us to find a similar expression. And so if we look in the formula booklet, we can actually find another formula for the double angle for cosine. So from the formula booklet, we get that cosine of 2 theta is equal to 1 minus 2 sine squared theta. And so the trick is to find the formula which has sine in it, since we want to find an expression for sine. And so we can do the same thing we did in question A. Let theta equal half of x. Substitute that in. So that'll be cos of x is equal to 1 minus 2 sine squared of half of x. And now we need to solve for sine of half of x. And so I'll move the cos on the other side, and the sines, 2 sines squared on the other side. And now I can divide by 2 and take the square root of both sides. So I divide by 2 and then I take the square root of both sides, and I should get 1/2 x here. Sine of 1/2 x, sorry. And we have the same interval here, this one. X is between 0 and pi, so x over 2 is between 0 and pi over 2. And sine from 0 to pi over 2 is positive, and so we can ignore the negative once again. And we'll have an expression for sine of half of x, which is similar to the expression for cos of half of x. It's just that here there's a plus 1, here it's a positive cos of x, and here's a negative cos of x. And also, actually, for A, I should put it in the same form that it's given in the question. So instead of cos of x plus 1, I'm just going to quickly change that to 1 plus cos of x. It's the same thing, it's just a bit nicer if it's in the same form. That's an x there. And C, hence find the value of the integral from 0 to pi over 2 of square root of 1 plus cos of x plus square root of 1 minus cos of x dx. So I'm just going to restate that integral here. Square root of 1 minus cos of x dx, okay. And so let's see. We have this word hence here, which means that we need to use the results from a and b to somehow find this integral. And if we look at the results, we'll see something familiar here. We have a root of 1 plus cos of x, which appears in the expression for cos of half of x. Okay, and this square root of 1 minus cos of x appears here. That's interesting. So what we can actually do is, since this is the expression is this divided by root of 2, we can multiply this whole thing by root of 2, and then we can multiply the integrand, or the thing inside the integral, by 1 over root of 2. So I'm just going to multiply everything inside the integral by 1 over root of 2, or in other words, I'll divide it by root of 2. And so now we should have this here. And you can just double check that these two are equivalent. Let me just scroll down here. And you can double check that these two are equivalent if you factor out a 1 over root 2 and you factor that out here, that'll just become a 1 and it'll be the same as this here. And so now we have this integral, and you should notice that we can sub in this cos of half of x for this expression here. And you should also notice that we can sub in sine of, oops, sorry, I'm trying to change color here. You can sub in sine of half of x for this expression here. So I'm going to quickly do that. Plus sine of half of x dx. Okay, and so now we need to integrate this whole thing. So cos of half of x, you can look at the formula booklet, or you should just know that the integral of cos is sine. And since there's a half of x, we'll need to multiply this whole thing by 2. And you can double check that this is in fact the integral of this. If you were to integrate, you'd get 2 cos of half of x times a half, and the 2 and a half will cancel, and so you would just be left with cos of half of x. And here we have sine half of x. The integral of sine is negative cos, and so this will become negative cos of half of x. Let me write that better. Negative cos of half of x. And again, the same argument applies. You need to pull out a 2. And remember, this is a definite integral, so we need to indicate that it goes from 0 to pi over 2. And now we can expand this, so we just need to sub in pi over 2 for x first. So pi over 2 times 1 over 2, that's just pi over 4. Minus 2, oops, let me scroll down. Keep forgetting to do that. So 2 cos pi over 4. And then we subtract, by this whole thing with x subbed in as 0. And so now you should note that sine of 0 is 0, so that whole term cancels. Cos of 1 is 1, so this is 1. Sine of pi over 4, that's one of the special triangles or special angles that you should know. This is pi over 4. So this side length is, or sorry, this is 1 and 1, and so this side length is root 2, and so sine of that is 1 over root 2. And cos of pi over 4 is also 1 over root 2. So I'm just going to write this here. 2 over root 2 minus 2 over root 2. You have a 0 here and a 1 here, so that's a minus 1. or sorry, that's a 2 times 1, so that's a minus 2 times a negative here, so that'll become a plus 2. And these two will cancel. And so we're left with the final answer, which is 2 times root 2. And there we have it.